Have you ever wondered why we only see one side of the moon every night? It looks frozen up there, the same craters, the same shadows, the same ancient face staring back at Earth, almost as if the moon is just hanging in the sky without rotating. But that is the illusion. The moon is rotating, it is moving, it is orbiting Earth at thousands of kilometers per hour. So why does it never seem to turn away from us? The answer is one of the most fascinating dances in space, a gravitational lock billions of years in the making. For thousands of years, humans looked up and wondered what was hiding on the other side. But the real question is not just what was hidden. The real question is, why was it hidden at all? Earth spins once every 24 hours. The moon orbits Earth once every 27.3 days. Different motions, different rhythms. And yet, somehow, the moon always keeps one face turned toward us. That is not luck. That is physics. Imagine Earth's gravity pulling on the moon like an invisible rope. But the pull is not equal everywhere. The side of the moon facing Earth is slightly closer, so gravity pulls harder there. The far side is slightly farther away, so gravity pulls weaker there. That difference creates a twisting force called torque. Billions of years ago, the moon did not always face Earth the way it does today. It spun more freely. But Earth's gravity kept tugging on it, stretching it, twisting it, slowing it down. Inside the moon, friction converted that motion into heat. Little by little, the moon's rotation lost energy. Its spin slowed and slowed, until finally, its rotation matched its orbit. It took 27.3 days to spin once, and 27.3 days to orbit Earth once. When those two motions matched, the twisting nearly stopped. The moon reached balance. This is called tidal locking, and it is why the moon always shows us the same face. But here is the part most people never hear. The moon's orbit is not a perfect circle. It is slightly stretched, elliptical. That means the moon is sometimes closer to Earth and sometimes farther away. When it is closer, it moves faster in its orbit. When it is farther away, it moves slower. But the moon's rotation does not speed up and slow down to match. It keeps turning at a steady pace. So a mismatch appears. When the moon is closest to Earth and moving faster, its rotation cannot quite keep up. Its face turns slightly one way. When the moon is farther away and moving slower, its rotation pulls slightly ahead. Its face turns back the other way. The result is a gentle cosmic wobble, a slow rocking motion in the sky. This is called libration. Because of libration, the moon does not show us exactly 50% of its surface. Over time, it reveals more. It rocks east and west by about 7.9 degrees. It also rocks north and south by about 5.3 degrees. And when all these motions combine, we can see about 59% of the moon from Earth. Not 50%, 59. That means the moon is locked, but not perfectly still. It is always shifting, always rocking, always revealing a little more of itself. Even the Apollo astronauts used this knowledge. Before missions, they studied lunar maps shaped by libration. They needed to know which craters could be seen from Earth, which areas were hidden, and how the moon's changing angle affected what we could observe. The moon's wobble helped humanity understand where it could go. And the far side? It is often called the dark side of the moon. But that name is wrong. The far side gets sunlight too. It has days and nights, just like the near side. It was not called dark because it lacked light. It was called dark because, for most of human history, it was unknown, hidden, silent, unseen. Libration gives us small glimpses around the moon's edges, but most of the far side remained a mystery until spacecraft finally flew around it and photographed what human eyes had never seen from Earth. And still, Every night, the moon continues its motion. It rotates. It orbits. Its path stretches slightly. Its speed changes. Its face rocks back and forth. A locked world that still dances. So next time you look up at the moon, remember this. It is not frozen in the sky. It is moving. It is wobbling. It is slowly revealing secrets it has kept since the beginning of time. And now, I want to know what you think. If you could stand on the far side of the moon and look back into space, what would you want to see first? Drop your answer in the comments.